Welcome to the second session of Mysterious Cosmos. Our previous one took you back to the medieval times when astronomy came into picture. Today, we'll be taking you on a tour of Indian astronomy. So, let's get started. Indian astronomy is divided into various phases: the Vedic era, the Siddhantic era, and the post-Siddhantic era. Vedic astronomy refers to Indian or Hindu astrology, a system that originated in India and was documented by the sages in the Vedic scriptures. Vedic astrology was the same as Vedic astronomy until the two got categorized as different subjects. All this was closely tied to religion, but despite this period saw a bunch of accurate predictions of phenomena. Be it the oldest Vedic texts, which just like the modern times, divided the year into 12 months, further into weeks, into days, and with their own leap years. To the cardinal points, the ancient Indians proved that they were excellent in their field. Their theories about the seasons and eclipses were so accurate that they correspond to the modern ones. Mysterious, isn't it? I wonder how could they do such marvelous things back in times when technology and equipment were non-existent. And we can't miss the astronomical charts, which are one of the greatest legacies passed on to the Western world. Well, as time passed, a new age of astronomy emerged, which diverged itself from the Vedas but had roots in it. This was called the Siddhantic era. This era witnessed the existence of great minds: Aryabhatta, Valmiki, and Bhaskara. As the maths was progressing, these minds made accurate assumptions about the astronomical distances, the circumference of the Earth, and even of Sun and the Moon. These are closer to the modern values than any others recorded in the olden times. Yajnavalkya, who in around 3000 BCE believed in a heliocentric universe. Remember I mentioned about heliocentrism in my earlier video, so if you haven't seen it or you don't know much about it, go and check it out. Coming back here, there was no one to contradict to his theory, because he provided proof based on simple observation. Also, the Catholic Church did not exist at that time. It came many years later. And the main reason the Catholic Church was against this idea of heliocentrism was because it thought that it was the work of Arabics. And at that time there was a controversy between the Arabs and the Catholics. In his text called Shapata Brahmana, Yajnavalkya measured the distance from the Sun and Earth and Moon. This came to be around 108 times the diameter of these bodies, which is close to the modern measurements for 107.5 for the Sun and 110.5 for the Moon. This period passed the greatest legacy ever inherited by the human race, that is of the number system, to other civilizations, time being progressive as always. Further, we saw the collaboration of Hindu and Islamic ideas, encouraging more and more people to take up space sciences. Many rulers made observatories and sun dials, the most famous and largest being the Jantar Mantar in Rajasthan, India, built by Savai Raja Jai Singh. During Islamic India, Akbar made great contributions to the field of astronomy, and though when India was annexed by the British, this progress slowed down, but in the 20th century, Indian scientists fascinated the world with their theories. The post-independence period saw the birth of Indian Space Research Organization. Quite a few would be knowing that ISRO started out in a Catholic church in Kerala, Thamba, which served as its workshop, and its first rocket was transported to the launch pad by a bicycle. Imagine a launch vehicle being transported to the launch pad using a bicycle. Fascinated, isn't it? And despite facing loss after loss during its foundational years, today they have come up to be one of the finest space agencies on planet Earth, being the first to successfully place a satellite in orbit around Mars, to breaking the world record by launching 104 satellites in one go. ISRO has proved that they're capable of doing anything. And further, they're planning to set up a space station of their own, another mission to the moon called Chandrayaan 2. And here comes the most interesting part. Around 20 years ago, ISRO asked Russia to build its third stage cryogenic engine. Russia was pressurized by the US not to do so. And today, after 20 years of tremendous research and development, ISRO has constructed its first It's a cryogenic third state liquid fuel engine which is the part of its GSLV Mark III rocket. So after seeing this, we can say that India's contribution to this field of astronomy is priceless. From Aryabhatta to Bhaskara, to Chandrasekhar to C.V. Raman. Indian astronomers and astronomy recounters can be credited with interesting theories and discoveries. The detailed mathematical treatment of science of astronomy can be traced back to 400 AD, but the origin of science itself can be traced back as to 5000 BCE. Some references regarding nakshatras, meaning constellations, solar and lunar months, are available in the Vedas. Then came the Siddhantic period, during which accurate assumptions about the orbits of Mars, Jupiter, Saturn and Venus were made, and other quantities like the sunrise, sunset, eclipses, the duration of the day. So with this, we have completed our mysterious journey through Indian astronomy and landed back at the present. So see you soon in the future. Till then, like, share, subscribe to the Mysterious Cosmos, and as always, #GetMysterious.